Welcome to the second video. We are studying trigonometry. Here are some topics that I want to go over so that we're all on the same page. We're going to convert from degrees, minutes, seconds. We're going to find complementary, supplementary angles. We'll define angles in standard position, and we will find coterminal angles. So before calculators, mathematicians used degrees, minutes, and seconds to describe bits of a degree. So instead of having like half a degree or a quarter of a degree, we actually have minutes and seconds, and they correspond to time. So we would want to be able to convert those things because you're going to see angles written in degrees, minutes, and seconds in your book, and I want you to be sure that everybody's on the same page and we know how to deal with them. So in terms of time, you know that an hour is 60 minutes. 1 minute is 60 seconds. So 1 hour would be 60 times 60, or 30,600 seconds. So if you know that, then you can figure out how they do degrees. Degrees, 1 hour is equal to 1 degree. So 1 degree would have 60 minutes and 3,600 seconds. So to convert DMS, degrees, minutes, seconds, to a decimal amount, you would see it written 20 degrees, 30 minutes. I want you to notice that's the symbol for minutes, and 40 seconds. So it looks like feet and inches. So they've kind of mixed everything that we already know together. All right, so to figure out how to do this, you would take 20 degrees plus part of a minute. So I have 30 minutes out of 60 total. I could have written 1/2. I could have written 3/6. It doesn't matter because I'm going to do it all on my calculator. And then I had seconds. So I have 40 of 3,600. And so from here, I would do this on a calculator and end up with a decimal number. So when I just enter 20 plus 30 divided by 60 plus 40 divided by 3,600, hit enter, I get, and I hope you're doing it too, 20.51111111 goes on forever. So these two things are equivalent. So now, what if they give you the decimal and they want you to convert to degrees, minutes, seconds? Well, we know it's going to be, on this very first one, we know it's going to be 20 degrees. And so we're going to use this partial degree to find the degrees, minutes, or excuse me, the minutes and the seconds, if there is one. All right, so I have 20 degrees, and I'm going to add to that 0.51 times 60, because I want to take 0.51, or 51%, of 60 minutes. So when I put that in my calculator, 0.51 times 60, I get 30.6 minutes. Now notice there's a partial minute, so I need to know how many seconds that is. So I'm going to do 0.6 times. Now this is where it's different, because I am not taking parts of degrees, I'm taking parts of minutes. So this, once again, is 60. So 0.6 times 60, and some of you are doing this in your head because you're awesome, is 36. So I get 20 degrees, 30 minutes, and 36 seconds. Now, is that not the same number that we did on the previous screen? 20.511111. What I did is truncate, or cut off, the repeating decimals, and therefore this number is slightly off from the number before. That's why truncating is going to get you less accuracy. I would like for you then to work this second problem in your notebook. Go ahead and convert it and have the answer ready when you come to class. Complementary and supplementary angles from geometry. We remember that complementary are two angles that add to 90 degrees. Supplementary angles are two angles that add to 180 degrees. So to find the complement means that I need to find the angle that's added to this that equals 90 degrees. So I have 90 degrees minus 38 degrees, 32 minutes, and 18 seconds. Well, I'm going to have to borrow. So I take a degree away. A degree is 60 minutes. I'm going to borrow one of those. That's going to leave me 59. Leaves me 60 seconds. So when I subtract, 60 minus 18 is 42 seconds. 59 minus 32 is 27 minutes. 89 minus 38 is 51 degrees. Once again, I would like for you to work this second problem in your notebook, remembering what the supplement is. Show your work, and I will be checking it when you come to class. If you recall from geometry once again, an angle is made of two rays that connect at a vertex. To put an angle in standard position, we know that this is the Cartesian coordinate plane, this is the x-axis, the y-axis, and this is the origin. We are going to place the origin, we are going to place the vertex on the origin so that our angle will have one side on the x-axis and then we'll extend up the other way. So this is the vertex, this is the initial side, and this is called the terminal side. The initial side is stationary. It does not move. I can't spell it, stationary. Okay, so the vertex is on the origin. The initial side is on the x-axis right here between the first quadrant and the fourth quadrant. Then, just like it moves in a counterclockwise position, and it actually can revolve then around, all the way around. You'll note here that if I have an angle that goes, see this red, the terminal side is the red, that looks like and is 90 degrees. If I have another angle, here's my green one, I think it'll let me do green, here, so in other words it starts at 0, this would be 0, the initial side, right? If the initial and terminal sides are on top of each other, it's 0 degrees, it hasn't gone anywhere. This is 180 degrees. And then I'm trying to find another great color. Let's see. Okay. Then if I have one that goes this direction, right, all the way around to here, this would be 270 degrees. And then all the way around is 360 degrees. Have you ever wondered why there are 360 degrees in a circle? I know, me too. We'll talk about it in a bit. You can actually determine where angles are in standard position, and you can determine what quadrant the terminal side of that angle is located. So for instance, if I have 87.9 degrees, that's going to be an angle that looks like this. The vertex is on the origin, initial side is here at 0, and it moves up 87.9 degrees. This is in the first quadrant. 150 degrees is bigger than 90 but less than 180, somewhere in here, right? So this one is in the second quadrant. 8.5, seems obvious that that would be in the first quadrant. 282, well, 282 would go all the way around to 270 and past, so it's in the fourth quadrant. Now these other three are negative. Notice that when we did a positive angle, we went in a counterclockwise position. Right? That's a positive angle. So if we go in a clockwise, I'm going to change colors, if we go this direction from the initial point, then that would be in a negative direction. So you have to kind of think of it backwards. So we know all the way around is 360. So if we want to do negative 336 degrees in 30 minutes, that's going to end up in the first quadrant because we're going in the opposite direction. Negative 12.35. If it were positive, it would be in the first quadrant, but it's not, so it's in the fourth quadrant. Negative 132, right? From here to here is 180. So 132 would be here somewhere. That would be the third quadrant. If you want to graph angles in a standard position, you would start with the 0 side, right? This is 0 degrees. This clear over here would be 180. So 150 would be somewhere right there. Negative 120 would still start at 0, but it would go backwards this way. Right? If this is 180 and this is negative 120, then this angle right here that's left has to be 60. Okay? 270 is positive, so I start at 0 and I go all the way around to here. That is 270. Notice that angles have their rays, so be sure that you put rays on them. All right, now this one's interesting because it's bigger than 1 revolution, right? In fact, it's at least 2 revolutions. So if I go all the way around once, that's 360. If I go all the way around again, that's 360 times 2, which is 720. So then I have to go how much more? 60 degrees more. And so my angle is here. Now, we show the revolutions because it goes more than one time around. Here's the interesting thing. If I just started, let me change colors, and if I just graphed 60 degrees, I would still start here, and I would end up here, right on top of this one. Because the terminal sides end up in the same place, the angles are said to be coterminal. They don't have the same degrees, but they end up in the same place. That's what makes them coterminal. So 780 and 60 degrees are coterminal angles. There are an infinite number of coterminal angles to any given angle on the graph. All you have to do is manipulate the revolutions. You might have to do a jabillion revolutions, but if you end up in this same spot, that angle would be coterminal. Jabillion is not really a term. I just like the way it sounds. All right, so this one, the only difference is here is that this is negative, so the direction is the opposite direction. It's also a multi-revolution, so you are going to start at 0. I'm going to go around 360 times. If I subtract 360 from 600, the positive 600, I'm going to get 240. Double check me. Yep. All right, so that means I've gone all the way around once. Here's 180. 180 leaves 60. So I'm going to do about 60 degrees here. All right, so if this piece right here is 60 degrees, then what is this right here, the red angle? Well, it's positive because it goes in a counterclockwise direction. If it's 60 to here and it's 180, this is going to be 120. So negative 600 degrees and 120 degrees are coterminal. Okay, so I hope you have these notes. I will see you in class, and we will explore some more of these topics later on. See you later.